Coming up next on the IP Talk stage, James Bong from Samsung, presenting Samsung Library and IP offerings.
Samsung is also a big memory chip supplier, and we leverage our memory technology to develop our logic process and also to ramp our fabs. So Samsung has a proven track record in high volume 300 millimeter manufacturing. On the right side, you can see our two facilities. The S1 line is located in Gihyeong, Korea, and it has been operating since January 2005. Last year, we also opened a fab in Austin, Texas in April. So Samsung is not only a foundry provider, but we also offer a differentiated turnkey solution. We have ASIC design centers in San Jose and in Korea. As well, we have design partners around the world. This means that we can perform services such as DFT insertion and layout and time enclosure. Through our design centers, we also provide validated IPs and libraries. As well, we have an advanced technology, package technology group, which is developing new technologies such as through-silicon via. Right now, we have package-on-package technology. So how does Samsung enable designs? If you look in the lower left corner, you'll see a few points about technology enabling. Sorry. So as I mentioned, ISTA is responsible for developing the process, but in parallel, we run many test vehicles to test the SRAM and logic silicon validation. As well, with our ISTA partners and EDA vendors, we develop new technologies such as double patterning technology, which is required at new process nodes such as 20 nanometer and 14 nanometer. As well, as I mentioned previously, we have an advanced package group that designs new 3D IC solutions such as through-silicon via. In the top left, you can see the different components of our PDK. This allows traditional foundry customers to do their custom logic and library and IP design. In the top right, you'll see DFM, which is important for new process nodes. We can provide a DFM kit for customers, but if customers don't have the tools or expertise, we are able to run DFM services on our side and also give feedback to the customer about how to optimize their design for yield. In the lower right, you can see what we offer in terms of libraries and IP. For libraries, we offer the standard cells, memory compilers, and IOs, and we also have different high-speed interface and mixed signal IP. So this is about our PDK. We work with ISTA and the major EDA vendors such as Cadence, Mentor Graphics, and Synopsys, and we provide different tool support throughout the design. You can see for schematic and layout work, we support Cadence tools such as the schematic editor and also Virtuoso. And in terms of models, we provide HSPICE and Spectrum models to support different devices. For like DRC LVS, we support Mentor Graphics Calibre tools as well as Synopsys IC Validator. And for parasitic extraction, we support all three vendors, Synopsys RC, Cadence QRC, and Mentor Graphics XRC. And of course, we provide like tech files and documents as part of the PDK. So in terms of IP, Samsung has its own internally developed IP, as well as we work with third parties. So when we work with third parties, we take care of all the licensing and also all the porting, so that when a customer actually uses the IP, it's all silicon verified and customers don't need to worry about it. Our library solution consists of two main parts. First is the backbone library IP, which is developed by a common platform. The libraries are provided by ARM, and as I mentioned, the partners are IBM Global Foundries. In the basic offering, our standard cell library has 9-track and 12-track libraries and also a power management kit. Our memory compilers, we have high density, high speed, single port, dual port register files, as well as a ROM. And for the I/O, the common platform library provides 1.2 volt to 1.8 volt I/O. The second part of our library solution is what we call our enhanced IP, and these are IP that has been either developed in-house or have been modified from the ARM libraries. For example, for the standard cell libraries, we have pulse flip-flops for high-frequency designs, and we have also have Alive and RTC libraries. For memory compilers, we've developed low voltage and low power memories. And for IOs, we've extended the IO offerings to support 1.8 volt to 3.3 volt IOs, as well as 5 volt tolerant IOs. And we also offer different memory interface IOs, such as for DDR2 and 3 and so on. For embedded memory, we have eFuse, which is mostly used for chip ID or also for memory BIS repair purposes. And also we have OTP. So this shows what we offer in terms of support for 28 nanometer LPP, which is available today, and also for 20 LPE, which will be released by the fourth quarter of this year. So shown here, the items in black are from common platform and are developed by ARM, and the blue items are from Samsung. So SoCs today contain a variety of IP, and these are all the IP that we can provide as silicon verified IP. So when customers use these IP, they can reduce their time to market and also enhance their first time silicon success. For processor cores, we support a variety of ARM CPUs and system IP. We support all the high-speed standard interfaces such as SATA, PCIe, USB 2 and 3, and so on. And as I mentioned on the top right, these are all the standard cell libraries. We support different threshold voltages and multi-channel length cells. And for mixed signal, we have a lot of ADCs, DACs, AFE, PLL, temperature sensors, and so on. So you can see here that 32LP is currently in mass production. Our 28 LPP process is currently under silicon validation. Many of the IPs are ready, but some are still not done yet. And 20 LPE is currently under development. This slide shows our ARM CPU leadership. ARM is gaining in popularity even in servers nowadays. And this shows that, for example, for 32 nanometer, we have 4 different Cortex cores running at different frequencies and number of cores. For 28 LPP, we offered Cortex A9 and A15, which are already available, and our Cortex A7 will be done by this month. And for 20 LPE, we plan to have a Cortex A7 and A15 to be completed by March of next year. Please note that these clock frequencies are all at a clock overdrive, a voltage overdrive of 1.1 of the nominal. So for example, for 32 and 28, our nominal voltage is 1.0 volt, but these are running at 1.1 volt. So that's all I have for today. Thank you very much. If you have any questions, please visit our booth. We have many experts waiting to talk to you. Thank you.
Any questions for James?
Other than DFM kit, do you have to supply any other design kit or tool kit for the designers? Or everything comes from off-the-shelf EDA vendors?
In terms of the EDA flows, EDA flows you can get from the EDA vendors. We partner with many of them, and yeah, they have the flows available.
Yes.
How compatible is your PDK with Global Foundry?
Oh, as I mentioned, that we are part of the common platform group. So for common process, a company.
They're cutting out.
So as I mentioned, for common platform, the PDK and the libraries are all common. So a company can tape out a single GDS and use it at any of our facilities. Yeah.
That is, are the ARM cores delivered as soft or hard IP?
So all the ARM cores that I mentioned previously are all hard IPs. Yeah.
Thank you. Thank you very much for joining us. Thank you, James.